Hello everyone and welcome to this grade 8 physics class. The topic is measurement in science. Now in previous lessons we learned how to find the volume of liquids. So in this lesson we're going to study how to determine the volume of regular solids and irregular solids. A solid can be regular or irregular. So let's first see how we can find the volume of regular solids. So the figures below are examples of regular solids. Cubes, cuboids, cylinders, and cones are regular solids. And to find their volume, we can start by measuring their dimensions, such as length, width, height, or radius. And then we use these dimensions to calculate the volume. For example, the formula to calculate the volume of a cuboid is volume of cuboid is equal to length multiplied by width multiplied by height. So if we can measure the three dimensions, we can calculate the volume of the cuboid using this formula. For example, if the height is equal to 2 meters, the width is equal to 3 meters, and the length is equal to 2 meters, then the volume of the cuboid is equal to, so we just replace the length and width and height by their values. 2 meters multiplied by 3 meters multiplied by 2 meters, and this gives us 12 cubic meters. Note that when the length are in meters, we will find volume in cubic meters. If the length, width and height were in centimeters, then we will obtain volume in cubic centimeters. For example, let's find the volume of this cuboid shown here. The length of the cuboid is 3 centimeters, the width is 5 centimeters, and the height is 1 centimeter. So if we multiply these dimensions, we will obtain the volume in cubic centimeters. So the volume for the first part is 3 centimeters multiplied by 5 centimeters multiplied by 1 centimeter, and this gives us 15 cubic centimeters. Now for the second part, we are asked to find the volume in cubic meters. This means that we need to multiply the dimensions and they should be in meters. So we need to convert the dimensions from centimeters to meters. So how do we convert a length from centimeter to meter? Recall that in 1 centimeter, 1 centimeter is equal to 1 meter divided by 100. So now we can convert these dimensions from centimeters to meter. 3 centimeters will be equal to 3 over 100 meters. 5 centimeters will be equal to 5 over 100 meters. And 1 centimeter will be equal to 1 over 100 meters. Now we have the three dimensions in meters, and we can multiply them to get the volume in cubic meters. So the way to multiply these three fractions is to multiply the numerator first. 3 multiplied by 5 multiplied by 1 gives us 15. 100 multiplied by 100 multiplied by 100 gives us 1 million. And when we divide 15 by 1 million, we obtain 0.000015 cubic meters. So to find the volume in cubic centimeters, we multiply the dimensions in centimeters, and to find the volume in cubic meters, we multiply the dimensions in meters. Now let us see how we can find the volume of irregular solids. An irregular solid does not have regular dimensions, which means that we cannot calculate its volume by measuring its dimensions. For example, the four figures here are irregular solids. So let's look at this rock. We can see that the width of the rock changes as we go along the solid. Same thing here for the cork. The height is not the same everywhere, as well as the width. So the dimensions are not regular, which means that we cannot calculate their volume using formulae. To find the volume of an irregular solid, we use what we call the displacement method. The displacement method is based on the fact that when a solid is immersed in a liquid, the liquid will be displaced. And secondly, the volume of liquid displaced is equal to the volume of the solid. So here, when the solid enters the liquid is displaced upwards, and the volume of liquid increases by an amount equal to the volume of the solid. Let us see how we can find the volume of an irregular solid using the displacement method. And in this case, the irregular solid is a stone. So first we place some water in a measuring cylinder, and reading at the lower meniscus, we see here that the volume of water is 8 milliliters. So here each division represents 1 milliliter. So this is 5, 6, 7 and 8 milliliters. We see that the initial volume of water V1 is equal to 8 milliliters. Next, we tie the stone to a thread, and the stone is gently lowered into the water. And as you can see, the level of water rises to 13 milliliters. So this is 10, 11, 12 and 13. So we say that the final volume of water, we call it V2, is equal to 13 milliliters. Now, since the stone will displace a volume of water equal to its own volume, here the volume has increased from 8 milliliters to 13. So the volume of the stone is equal to V2 minus V1, and this is equal to 13 milliliters minus 8 milliliters, and it gives us 5 milliliters. So this is the volume of the stone. Now there are several precautions that must be taken when carrying out this experiment. First, the cylinder must be on a flat horizontal surface. If it is not on a flat horizontal surface, the cylinder might be tilted, which will change the level of water in the cylinder. Next, the stone must be lowered gently to avoid splashing of water outside of the cylinder. So if the stone is lowered quickly into the water, water might splash out of the cylinder, which will change the initial volume of water V1. Thirdly, the volume is read at the lower meniscus. We must avoid parallax error by placing the eye at the same level as the lower meniscus. And 5, we must use a thin thread so that the thread's volume is negligible. As you can see here, there is a part of the thread that is underwater. So if it is too thick, its volume will add to the volume of the stone. So we must use a thread that is very thin so that its volume can be neglected. Now, what if the irregular solid is too big to be placed in a measuring cylinder? For example, a large stone. Now we can still find the volume of this stone using the displacement method, but in this case we use what we call a displacement gun. A displacement gun has a spout that points downwards. So here the displacement gun is completely filled with water. Any additional water that is added to this gun will overflow down the spout. We place a measuring cylinder underneath the spout, and when the solid is lowered into the water, it will displace the water, which will overflow into the measuring cylinder. So as you can see here, the volume of water has increased to 14 milliliters, since the stone displaces a volume of water equal to its own volume, so we can say that the volume of the stone is 14 milliliters. Now let's consider the case where the irregular solid is very small. For example, a paperclip. So here we have 8 milliliters of water in a measuring cylinder, and when we immerse the paperclip in the water, we can see that the water level rises by a very small amount. In fact, the water level has risen by less than 1 milliliter. So we cannot determine the volume of the paperclip accurately using this method. So how do we find the volume of small solids, for example, the volume of a paperclip? The way to do it is, first we find the volume for a large quantity of the paperclip, and then we calculate the volume of one paperclip. The following example will illustrate this method. So a measuring cylinder contains 8 milliliters of water. 10 paperclips are immersed in the water. The water level rises to 12 milliliters. Calculate the volume of one paperclip. So here is a cylinder with 8 milliliters of water. Here we have 10 paperclips, and the 10 paperclips are immersed in the water, and the level of water rises to 12 milliliters. So the volume of 10 paperclips is 12 milliliters minus 8 milliliters, and that's 4 milliliters. So if 10 paperclips has a volume of 4 milliliters, then the volume of one paperclip is 4 milliliters divided by 10, which is 0.4 milliliters. So this is how we find the volume of small irregular solids. So in this example, the reason we use 10 paperclips is so that the level of water rises by an amount that we can actually measure from the cylinder. If we use only one paperclip, the level of water will rise by a very small amount, and we cannot read the rise in volume. So we have reached the end of this video, where we learned how to determine the volume of solids. I hope this video was useful. Thank you for your attention. See you next time.